So let's continue with our discussion of the R script that does some commands for descriptive statistics with our three data sets, the California Schools data set, the World Development Indicators data set, and the current population survey, the CPS survey of earnings. So we have those three data sets over here in the environment window, CA School, Earn, and WDIM, and I'm going to scroll down to where we were covering some of these descriptive statistics commands. I'm going to make my window a little bigger here. The first command we have is a command called Stargazer, part of the Stargazer package. The syntax of the command is first the data set, then we give it just an option for how it should present the table. We tell it that we want to include the median in addition to the mean. We tell it we want the numbers to be presented up to 2 digits, and we give the table a title. And if we run this, then down in our console window, you see that we get the table. Here's the title. Now we can do this for the other data sets. So let's do it for the Earn data frame or data set. We click run there, and there we have the 4 variables that are in this Earn data set, 15,393 observations, right? And then we can finally do the WDIM data set. So, and notice the virtue of the script here is all I have to do is I have the same command. I'm going to be using this command over and over again. In fact, for you guys in Econ 42, every single problem set, you'll be running this command at the beginning. You'll just be changing the data frame name. So there's the WDIM data set. And I guess it has, don't know why it's spilling over to the other side. So we can take out the median if we want to, right? And you should experiment with this and play with it and see what happens when you change things. So we take out the median, and then we just have the mean, standard deviation, min, and max. We can go over to Google and type copy Stargazer, go over to Google and search for Stargazer in R. Usually I add the in R just so you know, it's really clear. And we get the vignettes for the Stargazer package of what it can do. And we'll just take a second to wait until it loads up. We want HTML things, but you can see there's a nice description here of how the program works, and a whole bunch of options. So I strongly encourage you to do stuff like this, which is take that command, Google search it, look at some of the vignettes, some of the tutorials, explore a little bit, change things, modify things, and you'll get a lot better at using R, and it doesn't cost very much time. It's, I think, usually a fun thing to do, to spend time doing that. So we'll come back to our script, and notice now we have some variants if we just want certain variables. If we want to subset our data set to just have the small class size and have a table for those, we can do that. We might have a subset to not be small class, with small class is equal to 0, and we get a table of descriptive statistics for those. And notice now we have 182 in the California Schools data set. We had 420, so there's 182 school districts that have small classes on average, or this is not small classes on average. We can also calculate frequency tables, so using the table command. Notice when you hover over the command, let's see if I can get it to reproduce. Well, now it's not doing it. I think it does it the first time. I'm not sure what their algorithm is, but we can count how many school districts there are in every county, or this is going to count how many school districts, there are in every county. So if we run this, we see that Sonoma has 29 school districts, Santa Barbara has 11, Santa Clara has 20, San Diego has 21, and then we can do the same thing by a two-way table. So we have how many school districts in the county and how many are small class. So that gives us this two-way table. So we have the county here, and then we have, is it small class or not small class? So Butte County, almost all of them are small classes. Humboldt County, small classes. Contra Costa, on the other hand, is large classes. Kern has a lot of large class. Los Angeles, as we might expect, right, is mostly large class school districts and very few small class school districts. We can also do tables of means of variables by another variable. So if we wanted to know, well, what's the test score mean for the small class school districts compared with the large class school districts? So we take the California schools data set, we pipe it. Remember, this is the pipe symbol, Control Shift M or Command Shift M on the Mac will get you this symbol. So we take the California schools data set, pipe it into the group by command, which says group the rows by whether they're small class, 0 or true or false, and then pipe that into the summarize command. And the summarize command says, create a new variable called TS mean that's going to be the mean of the test score and not take into account the missing values. So you have to tell R what to do about missing values, how R should treat them. So na.rm equals true means don't use the missing values, since they're missing, when you're calculating the mean. So if we run this command, click up here and run, and we see that the test scores are about 7 points higher in the small classes, right? When small class is true, those are the small class school districts. So we can try, we can do the max, we can do the min. We can also do a t-test for whether small classes have higher or lower test scores. So I run the t-test command, and notice I have the tilde here in the t-test command. So it's the test score by whether you're small class or not. T-test is for differences in means, and one important thing to remember is you can only do a t-test for difference in means with 2 categories, small class, not small class. You can't do it for 3 categories. In that case, you have to use other methods. You may have learned them in Math 8 or Almost 40, a method called ANOVA, analysis of variance. We won't be covering that in this class because we'll just switch to regression analysis for things like that. So here's the t-test. Just like we saw before, 650 for the large class, 657 for the small class. And the t-statistic here is, remember, it's only the absolute value of the t-statistic that matters, so it's about 4, and the p-value is 0.0000063, so it's well below our normal cutoff of 0.05, and so we would say these 2 means of test scores for small class and large class school districts is statistically significantly different. One is larger, it appears, than the other. We can do these descriptive statistics for the WDI data set. I won't go into that very much. Here's again the table where we take the WDIM data set, we pipe it into the group by. We're going to group by region, and then we're going to summarize. So we pipe it again. The pipe has to be on the end of the line, not at the beginning of a line. So the pipe has to be here rather than at the beginning of this line. So that's part of the syntax of this Dippler piping. So we take WDIM, we pipe it into the group by, we pipe that into the summarize command. We're gonna take the mean across the countries of the percent female in the population. And we see here that South Asia has about 2 percentage points less than North America, 50 versus 48.8, 2 percentage point less females in the population. That's a lot of women who apparently are not in South Asia. It's the subject I talk about in a class, Econ 135, Economics of Gender in Developing Countries. And finally, we have the earnings data set. You know, these are all obvious same commands. I'll leave them for you. So that's all we need to do for today. Since I haven't modified the script, I'm just going to shut it down and not save it. And I'm going to exit R. When I exit R, I'm just going to never save. I'm going to quit the session. So if some prompts you to save the workspace, I'm going to say don't save the workspace. In practice, it's a good idea to not save the workspace. Everything should be in your script. You should always just reproduce things from your script rather than loading it when you start R up.